are there? How big are they? Like, can I ride one? Things like that are really important,
That last one especially, can I ride one?
Yes. Could I just sit on one? Like, all cute on the edge of one, like it's a little like horse that I'm riding or something like that.
Hi, I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started.
Welcome to lesson 82. We are in our deadly solar system unit. Cheryl, what is next on our list to find out how it would kill us in our solar system?
Well, Ryan, you see, after Mars are some other things that come next.
That's
namely,
true. Do you know what they are?
I don't remember. I could probably list the rest of the planets, but not necessarily the order that they're in.
And actually there's something that shows up before the planets, Cheryl.
What?
Do you know what else is in between Mars and the next planet?
A lot of space, probably.
Yes. And the asteroid belt.
Oh, fun.
Have you heard of the asteroid belt?
Yeah, I totally have.
Yeah. So that's between Mars and the next planet, which I'm not going to give away because that'll be our next lesson after that. And I want to find out if you can figure out which one it is.
Oh gosh, goodness gracious. I'm trying my best not to Google anything too, so this can be more like authentic learning, but it's difficult. Yeah. Okay, so asteroids. So Ryan asked, I think asteroids sound really fun. I definitely think about Star Wars, like dodging around asteroids. I'm sure there's been other, I feel like they come up a lot in like various film and movies, cartoons, you know what I mean? Like if someone's in space, I feel like asteroids happen. But I think what I don't really know about them, I don't really know like how many are there? How big are they? Like, can I ride one? Things like that are really important,
That last one especially, can I ride one?
Yes. I mean, can I ride an asteroid? And like, I guess what I mean by that, well, first of all, like, could I just sit on one? Like all cute on the edge of one, like it's a little like horse that I'm riding or something like that.
Okay.
Yeah. But also like, what are they doing? Are they also revolving around the sun, similar to a planet? And do they all just hang out right next to each other? I'm guessing so, because there's like, they're called the asteroid belt. So I'm guessing that there's like a cluster. Why are they clustered near each other? Is there any form of gravity on them? I mean, not enough that they'd be considered a planet or anything, but like if I wanted to ride an asteroid, would I have to hang on it on my own? Or if I got near it, would there be enough gravity that I could sit on it and stay seated? How big are they though? Like, is it like I could sit on it like a little park bench? Or is it like closer to like the moon? I'm guessing not though, because I don't know. Do we really say like we can see the asteroid belt in the sky? Maybe though. Isn't that kind of what one of the shooting stars is when we talked about shooting stars like a million years ago?
Oh,
I feel like we
memory.
talked about different things that cross our path that we call shooting stars, and I don't remember if asteroids were one of them. I know, asteroids, but like the asteroid belt, I don't remember. I think it was. I think there's like a time of year. I don't know. So they're big enough that we could like see light from them, kind of, if they're colliding with things, maybe like to create, because they don't like produce light on their own.
Okay.
Yeah, but can I ride an asteroid? That's my question for the day.
Okay. Well, as a part of the pre-assessment, let's find out what your thoughts are for a lot of these questions. But let's start with, what do you think an asteroid is? Like, what is it made of?
I think it's a space rock.
Space rock. Okay.
I just think it's a big rock. I think it's a clump of dirt/rock. I'm picturing holes, again, maybe because of Star Wars. I feel like they were like uneven with like it almost was like the Swiss cheese of rocks or something like that. Didn't they go in one and then like a monster, they were in its belly for a little bit? Was that in an asteroid?
Yes, they did.
Okay.
Yep.
You're allowed to tell me that because that's Star Wars, not our lesson.
Oh,
so
yeah. And yeah, Star Wars is amazing, of course. Okay. Another question you asked was, what are the asteroids doing? Like, what are they doing in the asteroid belt? You were wondering if they were revolving around the sun or not. What do you think?
I think yes, because I think everything in our solar system is revolving around the sun because it has that much of a pull that otherwise it would just go off wherever else. So it's got to be. It's got to be impacted by the gravity of the sun, just like we are.
Okay.
I would think. I don't know why they're all clustered together.
Yeah.
Though. I don't understand. Like, do they have any source of gravity on their own that keeps them clustered together? Or if not, like what else makes them want to stay together? Is it just that they happen to already be together? And so now they all stay at the same speed as they revolve around the sun? Or is there another reason that's keeping them together?
All right. So what do you think? You asked a lot of questions, but what do you think about those? Gosh. Do you think they have their own gravity?
I mean, if there's like a big one, or if there's like they each have a little bit, but then they all just want to stay together. I mean, when I think about the trampoline analogy that you gave me, like if you put a bunch of marbles on a trampoline and then like something was moving, I feel like they would all just want to stay together. Like they all kind of would go to the same spot. And I can't tell you why, other than that's like the lowest spot. So I don't know if that works or is the same, but like I just think like a lot of objects. But then all of our planets aren't like trying to stick together. So then that feels like that can't be the only thing, you know?
Yeah. Let's dive into the question, why are they near each other? And I'm actually going to ask a one step deeper question on that, since I can tell you're not quite sure why, and that's what you're trying to suss out right now. How near each other do you think they are?
See, this is so influenced by Star Wars and probably other things too, is I'm picturing if I was in a spaceship, I would have to be dodging them.
Okay.
But I don't know if that's from any source of reality or if that's just from sci-fi movies. So then
what do you think?
Gosh. Well, movies aren't always accurate, it turns out.
What?
Maybe they're...
Except when it comes to science. They're super accurate when it comes to science all the time. He said sarcastically.
I don't know. I'm guessing they're further apart than I think. And that's such a vague answer. But I'm like, I don't know. Because what I want it to be is that you can like hop from asteroid to asteroid. But I don't think, or like if I was in a spaceship, I'd have to dodge them. I don't know if that's true. I feel like maybe it would take some time to travel between them. I also don't know how many they are. Are there hundreds? Are there thousands? Are there tens? There's enough that we bothered labeling it because there's a lot of other stuff in space. That's true. So it must be significant enough. So I'm guessing there's a lot of them. But like, is the whole span of them like the same as the width of Earth? Or is it the same as like the distance between us and Mars? I mean, like how far do they span? And are they in a line? Are they in a cluster?
What do you think? Keep asking questions, which is great. They're great questions, but what do you think the answers to these are?
Gosh, I'm trying to think about what would be a significant span in space, because space is so big. It's very hard to have any guess that's going to be close to reality.
Yeah.
Just because like everything's so much bigger than our little planet that it's hard to picture it. I would guess they span like somewhere around the size of a planet. Now that's very vague because planets are different in size, but
yeah,
I guess it's like enough space that it's like a planet. That they're little bitties. I don't know how small they are.
Okay. And one final question that brings this into our unit theme, Cheryl, which is, how might asteroids be dangerous to life on Earth?
Ooh. Well, if they could hit us, I guess. Like I don't know how, if they're all revolving around the sun, but if any of them like broke off or something, then I could see them like hitting our planet by like us colliding with it.
Okay. How likely do you think that is?
Well, I'm guessing isn't that one of the things that does hit our planet sometimes, but it's not big enough that it's a big deal? But like, so I'm guessing it's not very likely that it'd be one that's a really big deal. That's like, oh my gosh, we're going to have like a significant loss of something or other on our planet.
Okay. Do you think it's ever happened before?
Yeah. Isn't that one of the dinosaur theories?
What do you mean?
An asteroid or something else, or is it a comet? Comets are different than asteroids, so. The comet, and I know, and this is what's bugging me, is I know we talked about it when we talked about shooting stars. We talked about
yes, but that was lesson number 1, Cheryl. That was the very first lesson that we did however many years ago now.
Okay.
So.
Okay, that makes me feel a little better. Yeah, I'm guessing something's hit Earth from the asteroids. I don't know.
Okay. And how close do you think an asteroid would have to get to Earth for us to be worried? Do you think it needs to get like as close as Mars or Venus, as close as the moon, closer than that, farther than that? What do you think?
Well, I think that scientists would be worried far before we would know about it. Would be, you know what I mean? Before it, but if they're like guessing,
they'd be worried before we know to be worried.
No, before we would like see it ourselves.
Oh,
like before it actually was in the place where it'd be worrisome. So I'm guessing if they were like, oh my gosh, it's going to be in our path, I'm guessing it would, well, if it's in our atmosphere or if it's in our gravitational pull is what I'm guessing it would be impactful to us. So like the moon is impacted by our gravitational pull. I don't know how far beyond the moon something would also be like sucked into the planet and how much it would just be like hanging out in space. Somewhere around the moon's distance.
Okay, great. Let's start, Cheryl, with what actually asteroids are. And you were more or less on the right track. They are big, giant rocks in space. I wouldn't say that they really have dirt per se. Dirt's more kind of an Earth thing.
Okay.
But yes, like they small rocks, sand-ish. I mean, not really sand like you'd think of on a beach, but yeah.
Okay.
But mostly, rocks. The shapes and sizes and compositions really vary from one asteroid to another. A lot of them have craters and they're kind of craggy, like you described. They're not generally, roundish, although there are a few asteroids that actually are, there's one in particular that's big enough to be considered a dwarf planet, Ceres.
Whoa.
So it's big enough that it actually is more or less round in shape.
Wow. Interesting.
Yeah. And sometime we may talk about this, but when it was first discovered, it was actually classified as a planet.
Oh, just like Pluto.
Just like Pluto. And then just like Pluto, we discovered more and more objects like it. And that's actually how we discovered the asteroid belt, was more and more objects. We're like, oh, well, maybe this isn't another planet, because then all of these things would have to be planets. And so then it got reclassified and they created the category of asteroid. Asteroids are, in fact, revolving around the sun. You are correct. They are doing that. And they are not close to each other.
Oh, so I can't dodge them or hop from one to another.
You can't hop from one to another. As a matter of fact, if you were sitting on one and you looked out into space, you would not see others.
Oh, okay. They're really not close.
They're not close, and most of them are not very big. So the combination of those together makes it, not so big a deal. Here's a few facts from NASA. The asteroid belt is estimated to contain between 1.1 and 1.9 million asteroids larger than 1 kilometer.
Oh, yeah. So a significant number.
Yes. And if you want to go smaller than 1 kilometer, there's probably millions of those as well.
Oh, my goodness.
So there's a lot of them. But the amount of space they take up, you were wondering how wide, how big the asteroid belt is. Are you familiar with the measurement called the astronomical unit, or AU?
I've heard of it. Okay. I've heard that name. I don't know what it means.
1 AU, or astronomical unit, is the average distance between the sun and the earth. It gives us something that we're more or less familiar with as a reference.
Oh my gosh, that's so self-centered, but it also does make sense. It sounds like a foot being like, oh, it's the length of the king's foot, because why would it not be?
Yep, exactly. That's exactly what it is. But it allows us to make really, really big numbers, because that's 93 million miles or 150 million kilometers. Those are really big numbers. We can just call it 1 astronomical unit. So it makes those numbers easier. And it gives us a reference point, since even though we don't know how far away the sun is, we have an idea, just a concept of, because we can see it in the sky, right? So the width of the asteroid belt is about 1 astronomical unit.
Okay, so it's
the same distance. The distance between the sun and the earth. If you were to fill that up, that space, and then all the way around. Except, of course, because it's farther out, it's a lot bigger around, right? Because as you get farther away from the center of a circle, it's bigger. There's a larger perimeter, right?
Yeah, that makes
circumference,
sense.
I guess. Right. So
interesting.
So it's a huge amount of space that has all of these rocks in it, and some of them do run into each other. That definitely does happen. But since space is mostly empty space, including in the asteroid belt, it's not like it's happening all the time. And unfortunately, it's not like in Empire Strikes Back in Star Wars, where they're like dodging and doing all that stuff. Now, they do look like asteroids look.
So in the galaxy that Star Wars takes place, their asteroids are much closer together than our asteroids here in our solar system.
Sure. You can look at it that way if you want.
Great. You can look at it that way if you want, Ryan.
Yeah, I could. Or maybe it was a planet or a planetesimal that got exploded by the Death Star or something, and that's what they were going through. It wasn't, but maybe. You never know.
We haven't seen that film yet.
Why are they near each other, or why are they all in that same region? That was another question that you asked.
Yeah.
And there's a couple of ways to talk about that. And one is, how did they form? Why are they there? And then another one is, what keeps them there? And you started talking about gravity and whether or not they had gravity and things like that. The first part, with why are they there in the first place, is they are left over from the formation of the solar system. That's how we think the solar system more or less formed, were all of these rocks that eventually smashed into each other and got bigger and bigger and had more and more gravity and were able to pull in more to eventually form planets. However, because of their location between the Earth and whatever that next planet is that you aren't sure, but they are the gas giants, so they're really, really large, which means they also have huge amounts of mass, that the gravity between our two planets, or I guess Mars, I guess is closer, actually prevented any objects that were in that area from actually forming together to form a planet. That's what we think anyway.
Oh, that's so interesting. Wow. So there is enough stuff there that if they were all together, they'd be a planet, but it's just like I don't know how big, their own pull, because there's such a big pull nearby.
Right, that disrupts them. Yeah, so they're not able to form together. And now they're more or less in a stable orbit, so it's not like they would be coming together anyway. But the other piece is, asteroids they all have gravity. I think we talked about this before, but all objects with mass have gravity.
I have gravity.
You do. You do. And so all asteroids do as well, but they're not very big. So we don't see the effects of the gravity of the asteroids all that often, but they do. And that's actually how we believe the early solar system formed, was all these objects that got close enough to each other and started to stick to each other. And then as they got bigger, then they were able to attract other objects and get bigger and attract other objects and so on.
Like obviously, the amoeba game.
Like amoeba tag, exactly. That's obviously an oversimplification, but
that's so cool.
A couple other things that we talked about were whether or not we could be destroyed by an asteroid. And you were like, I think maybe the dinosaurs, and then you weren't sure if it was an asteroid or a comet.
Yeah.
And good memory, yes, about 66 million years ago, there was an asteroid impact that we believe led to some of the events that also led to the extinction of the non-avian dinosaurs. That means the non-bird dinosaurs. Although there is some evidence that they were kind of potentially on their way out already, and maybe were not doing great prior to that, but that definitely did them in as well. Just for reference, the size of that particular asteroid was about 10 kilometers in diameter, which is just over 6 miles wide.
That's it?
That's it. So it doesn't take a super big asteroid to have a pretty big impact on Earth, which sometimes can be kind of scary because there are a lot of asteroids that are that size that are relatively nearby in the asteroid belt.
Interesting. Do we have times where our revolution is closer to theirs, like times of the year where we're like closer and further away, or are we pretty like parallel?
That's a good question. I mean, I think the answer, it would be technically yes, there are times, because there are times where we're technically closer to the sun and farther from the sun. And I'm guessing that would also put us closer and farther from the asteroid belt, but I don't think it's enough to make a huge difference, is my guess.
Significant. Okay. Yeah.
Yeah.
And then I remember in our Shooting Stars episode, you were talking about how there's a time of year, I think in the summer, where we see a lot of meteors.
Yes.
And are those related at all?
Not really. The meteor showers, like for example, in relatively early August, usually around like 10th through the 12th of August, is the Perseid meteor shower. And what that is the tail of a comet. The Earth passes through the leftovers of the tail of a comet. So not so much the asteroid, but the comet side for that. But yes, good memory with that.
Kind of.
Yeah, kind of. And then the final thing is, how close would an asteroid have to be to impact Earth for us to be afraid, all of those sorts of things. Now, hopefully this doesn't freak you out too much. We are monitoring, and scientists are looking for asteroids and other small solar system bodies all the time. But because they're so small, we don't always see them. And I just did a little bit of internet searching and discovered that the most recent was just in July of 2023, July 13th of 2023, we had an asteroid, a small asteroid, but pass about a quarter of the distance between the Earth and the Moon. So pretty close.
Wow.
To the Earth. Now, it's obviously it didn't impact, so it wasn't a big deal. And that does happen. We definitely have asteroids that get past less than the distance of the Moon from the Earth by us a few times a year.
And sometimes, it's not enough that it sucks it in. I guess it depends on a lot of factors, right?
It does. It depends on the size. It depends on the speed that the asteroid is traveling. And it depends on the trajectory, the path of its orbit. If it's headed directly at where Earth is going to be, then that's a problem. Or close enough that Earth's gravity would pull it into itself, then that's a problem. But so far in recent human history, we haven't really had that. There've been a few times. I don't know if you remember, I want to say it was in 2013, I think, over part of Russia. There was something that exploded in the atmosphere. It didn't reach the ground. Do you remember? And there were like videos from like their dash cams and things.
Kind of, yeah.
Let me see if I can find it.
Okay.
All right, this is a compilation of some different dash cam videos. So I don't know if you can see, they're going from the top left. Do you see how bright that is?
Oh my goodness.
Yeah, and then you watch and it just kind of like starts to break up. You can kind of see the space.
Wow.
Yeah.
That'd be
now this
scary.
next one, listen to this. Did you hear that big boom? It like broke. So that was the shock wave from the explosion. When it exploded, it just took time for it to reach the surface of Earth. So we were looking at the smoke up above, but once it hit, it was so strong, it actually broke some of the glass in the windows. Oh, there it is. That's off to the right over there, if you see it.
Yes.
Yeah. So that's far enough away that they're probably not going to hear the boom on that one. But yeah.
Wow.
Oh, there it is on the top left there. Yeah, so I mean, these things happen. And again, that one exploded in the atmosphere, and yet it still caused damage because it actually exploded. And if they hit the Earth, there's even more that you can get with that because you actually have the impact of the whole thing. So.
Do they have an estimate of how big this one was before it impacted
our atmosphere? We didn't know that it was coming. We didn't know it
so they
until
don't really
it
know
was
how
seen.
big it was.
There's an estimate. I'd have to look it up. So give me a sec, and then I can give you an estimate. It looks like they estimate that it was about 18 meters, or just shy of 60 feet in diameter.
Wow. That's so interesting.
Not very
big,
comparatively speaking, of a lot of asteroids, but big enough to have an impact. So there you go. No worries. You can sleep just fine tonight.
No, I mean, if it's going to happen, I don't know. There's nothing I can do differently. So whatever.
We could send Bruce Willis up with a nuke. That's what we could do.
I just recently watched that movie.
It was Armageddon, right? That's the one.
Yes. Yeah. I've never seen it.
Yeah.
Just watched it recently. Yeah.
Oh, and now your life is so much better that you've seen it.
I mean, it was an interesting thought to start thinking about what scientists are paying attention to. That, and also Don't Look Up, the more recent one.
On Netflix. Yeah.
Yeah. Yeah. And I was like, I mean, it's not like everyone's going to catch everything, but it's just interesting thinking about like what all scientists are up to out there. Was kind of cool.
Yeah.
So
yeah, that's true.
But Ryan.
Yes, Cheryl.
Can I ride an asteroid?
Can you ride an asteroid?
Mm-hmm.
I'm going to let you answer that as part of your quiz.
Okay, fine. I'll wait.
Which means let's just dive into that quiz right now, Cheryl.
Oh, gosh, no. I'm kind of hoping I'll get hit by an asteroid first, but I don't think it's coming right now. So I guess I'll just
hope not.
Deal with this. Yeah.
Yes, I think this is the lesser of two evils. First, where can you find the asteroid belt?
In the sky. It is past Mars.
Yep.
And before the beginning of our gas giant friends.
Yes, which you're not quite sure which one that is next.
There's one of them up there next. Yeah.
There's multiple next. Yes. How big is the asteroid belt?
1 AU.
Which is?
Length. 93 million miles or 150 million meters.
Kilometers. Yeah. Nice job.
Kilometers. Well, I remembered the 150 because it's more of a reasonable number than a 93, but
that's metric system fine. For the win.
Yeah.
How many asteroids are there in the main belt?
Asteroids that are over 1 kilometer in diameter, I think is what you said. It was over 1.1 million, I believe.
Between 1.1 and 1.9 million, somewhere around there.
Okay. And then below that, millions.
Correct. Yes. What would you see if you were to be on an asteroid?
Well, I'd see the asteroid.
Okay, what would that look like?
Swiss cheese rock. Some of them are rounder if they're a little bigger. Some of them are a little cavernous and clunky, sounds like. A little unshapely or very shapely. And then in the sky, I would see stars and distant planets every once in a while in the sun, and it might look kind of like the sky looks on Earth in a way.
Would you see any other asteroids?
No, I would not.
So could you jump from one asteroid to another?
No, I can't. I'm bummed about that part of it.
Yeah. Where did the asteroid belt come from?
From the beginning of our solar system, where there were just a lot of things like that floating around. And then these are our little solar system fossils up there to show us where we came from.
I mean, you're not really wrong with that. So that's actually a good way of looking at that. As a matter of fact, believe it or not, we've actually sent probes to land on asteroids and get samples, because it does give us information about the formation of the solar system in the early solar system.
Cool.
Yeah.
So those probes get to ride an asteroid?
Well, they more like bounced off of an asteroid. Really.
Oh. Wow, that's a fast sample.
Yeah.
They're just like out there with like a spoon, like ready to scoop.
Yes, a spoon. Exactly. That's what they use.
Get close enough. I don't know how people take samples.
With spoons, definitely.
Okay, great.
And the last but most important question of your quiz, Cheryl: can you ride an asteroid? Justify your answer.
Ooh, so I want to say yes, because I definitely can sit on one.
Okay.
Because like they're not teeny tiny by any means, and so I could sit on all sizes of asteroids, really. I think I can ride an asteroid the same I can ride planet Earth. So I don't know if ride is the right word necessarily. So that's where it's like a yes, but, because it depends on how we define that word and what it means. Because if I found a little asteroid, then I might call it riding it, but I don't know if it would have enough gravity that it would want to be ridden. So then I might have to like put a saddle on it or something like that. And it would be difficult, I think, to stay nearby it, maybe, I don't know, without like hanging on, which I guess I could do. And then the ones that have enough gravity that I actually could like walk on them or sit on them without just like going off elsewhere in space, I guess I could ride it, but I also then it'd just be like walking on it or sitting. It wouldn't feel like a I don't know, rodeo around the sun or anything like that, or like riding a rocket ship. Yeah. So technically yes, but I don't think we would use the word ride.
I like your answer. That's a great answer, Cheryl. That's all the time we have for this week's lesson. So why don't you pack up your stuff and get ready for my closing remarks.
You can follow us on Instagram and Facebook at I Slept Through Science, or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.